Okay, what if I told you that the path to a global deep freeze was actually paved with heat? Yeah, it sounds completely backward, I know. But some fascinating new research is showing this incredible, kind of weird link between global warming and the most extreme ice ages in our planet's history. So how on Earth can fire lead to ice? Well, let's dig into this climate puzzle.
And that really brings us to the big question, right? Is the global warming we're seeing now actually going to lead to the next ice age? It's a question that totally flips the script on how we think about this stuff. Now, to be clear, the idea isn't that warming is cooling. It's more that warming can kick off these powerful, really long-term feedback loops that eventually could slam the brakes on the climate and send it into a deep freeze.
So, to really get our heads around this new discovery, we've got to go back to the classic idea of how our planet keeps its temperature in check. For a long, long time, scientists have basically thought of Earth as having its own built-in natural thermostat. And the key to that thermostat? It's a process called chemical weathering. Now, what that really means is it's this super slow, really steady balancing act. Think of the rocks on our planet, like all the mountains and stuff, acting like a giant sponge, just gradually soaking up CO2 right out of the air. It's this process that's supposed to stop the climate from going haywire, from getting way too hot or way too cold over millions of years. So, let me break it down. It basically happens in 4 steps. First, you've got CO2 in the atmosphere dissolving into rainwater, which makes the rain a tiny bit acidic. Okay, then that acidic rain falls on rocks, things like granite, and it slowly breaks them down. Third, all that dissolved carbon gets washed into rivers and flows out into the oceans. And finally, it gets locked away. It becomes part of the seafloor for like millions of years. And this is where the feedback part comes in, which is pretty genius. A geologist from UC Riverside, Andy Ridgewell, put it this way. When the planet gets hotter, this whole rock weathering process actually speeds up. So hotter temperatures mean rocks break down faster, which pulls more CO2 out of the air, which, you guessed it, cools the planet back down. See? It's supposed to be this perfect, self-correcting system. But there's a problem. A big one. Because when scientists started looking way back into Earth's geological history, the evidence they found just didn't match up with this neat and tidy thermostat idea. It was like there was a major glitch in the system. And here's the contradiction, which is really the heart of the puzzle. On one hand, the theory says you should get a pretty gentle, stable climate that corrects itself. But on the other hand, the evidence from the rocks points to these ancient runaway ice ages. We're talking about snowball Earth events, where pretty much the entire globe was covered in ice. A gentle little thermostat just doesn't explain something that extreme. No way. So this puzzle is what pushed those researchers at UC Riverside to hunt for a missing piece. They figured there had to be some other mechanism, something powerful enough to just completely override that rock thermostat. And you know where they found it? Not on land, but deep down, in the oceans. And what they found was this incredibly powerful runaway feedback loop. And it all has to do with 3 things: nutrients in the ocean, these tiny little organisms called plankton, and the amount of oxygen in the water. This was the hidden switch, the thing that could flip the planet from hot to, well, unbelievably cold. Okay, so how does this whole runaway switch actually work? Well, it all kicks off with warming. A warmer world means more nutrients get washed from the land into the ocean. Think of it like fertilizer. This causes these huge blooms of plankton, and they suck up a ton of CO2. But when all that plankton dies, it sinks and decays, and that process uses up all the oxygen in the deep ocean. And here it is, this is the really critical part. When the ocean has low oxygen, the seafloor itself starts releasing even more nutrients, and that just fuels more plankton, which means more decay, which means less oxygen. You see where this is going? It becomes this powerful self-reinforcing cycle that just yanks massive amounts of carbon out of the atmosphere and buries it. So you see, this ocean process doesn't just gently nudge the climate back in line. No, it can dramatically overshoot. It's like it slams on the brakes so hard that it sends the whole planet careening straight into an ice age. And I absolutely love the way Andy Ridgewell explains this. He uses this great analogy. He says, imagine the thermostat in your house isn't right next to the air conditioner, but it's all the way on the other side of the room. The AC just keeps blasting cold air, right? It totally overcools the room, long before the thermostat way over there even realizes what's happening and tells it to shut off. Well, that's kind of what Earth's climate system can do. Okay, so that raises a question, right? Why was this feedback loop so incredibly strong in the distant past? I mean, strong enough to trigger a full-on snowball Earth. Well, the answer, it turns out, was in the air itself. See, way back in Earth's early history, the atmosphere had way, way less oxygen than it does now. And that made the whole ocean nutrient cycle much more sensitive, much more unstable. It was just primed for that runaway feedback to get completely out of control. But today, our oxygen-rich atmosphere acts like a buffer. It makes the whole system more stable and really weakens that feedback loop.
Which, of course, brings us all the way back to our first question and what this all means for us right now. Is it possible that today's global warming could somehow save us by kicking off one of these cooling periods? Well, the short answer is absolutely not.
I mean, the timescales we're talking about here are just immense. Any kind of cooling that might be triggered by these geological processes, we're talking tens of thousands of years minimum before it would even start. So for the warming we're causing right now, it's completely 100% irrelevant. And that really is the critical takeaway here. Again, Andy Ridgewell puts it perfectly. He says that the idea that the Earth will eventually cool itself back down, in its own slow, kind of wobbly way, that offers zero comfort and zero solutions for the problems we're facing in our lifetime.
So, look, while this ancient mechanism isn't going to swoop in and save us, it is a really powerful reminder of just how complex Earth's climate system is. It's capable of these surprising, really dramatic shifts. And that leaves us with a pretty big question to think about, doesn't it? As we keep pushing our climate into totally new territory, what other surprises, what other feedback loops and overcorrections might we be waking up?